Good morning, Dr. Natai.
Good morning, Mr. Beaumont.
How are you, sir?
I'm well, thank you. How are you, sir?
I'm well. I was just a bit concerned about you last night.
I'm so
Was
sorry about last
was it
night.
your laptop?
It was my laptop, and I'm not in PE currently, so I'm working from home. That is the rural areas.
Okay, oh, okay.
So the
No,
network
no. I was
is
just a bit concerned because I remember you saying about your laptop. But
mm,
I mean that's
no,
fine.
yeah.
No, it's no problem. I'll be in and out of the session. I've got another session at 10, and then I've got your other will you be having your other session now at 12 o'clock as well?
Yes, I've got another one at 12 o'clock.
Okay, perfect, perfect.
That's-
Okay, so I don't think there's any need to kind of have a make-up or whatever, because students will say what they need.
Yes.
Um, but you can decide, you can speak to the class, and then you can see what happens. Okay.
Yeah. Okay. I'll
Okay,
do.
Doc. Okay then. Okay.
Okay, thanks, man. Good morning, students. Um, Welcome to another session of our BNU 1501. Today we are looking at factors, fractions. Okay, I don't think we're gonna have time to look at percentages and ratios. And then we will look at some question papers just to see the examples and the style of questioning as well. Okay, let's jump. I don't think we have to wait any longer. I think let's just jump into it. Um, can you guys indicate if the document is up? Is it visible on your side?
Yes, it's visible, Doc.
All right, thank you. Thank you. Okay, so after the lesson, you should have the skill to determine all the factors of a certain number. You should determine the lowest common multiple or the LCM. Should perform basic operations on fractions and decimals. The last one, I don't think we're gonna get to it. That is performing the basic operations involving percentages and ratios. Okay, the first thing that we're looking at is finding the multiples or the factors of the numbers. So what is a factor? So all integers have factors. Some numbers have more than one factors. So a factor of a number is a number by which it can be divided without leaving a remainder. One and the number itself are always factors of a certain number. Okay, so we're looking at the examples. The factors of 6. If 6 is being divided with 1, the answer is 6. And if 6 is divided with 2, the answer is 3. So if 6 is divided with 3, the answer is 2. And if 6 is divided by 6, the answer is 1. Therefore, the factors of 6 are all the numbers that we've listed, that is 1, 2, 3, and 6 itself, because all these numbers divide exactly into 6, and they don't leave any remainder. If we write 6 is equal to 2 multiplied by 3, that is, we have written 6 and its factors. We say we have factorized 6. So if 8 is divided by 1, the answer is 8. And if 8 is divided by 2, the answer is 4. If 8 is divided by 4, the answer is 2. If we divide 8 by 8 itself, the answer is 1. Therefore, all the numbers that we've listed are the factors of 8. And that is 1, 2, 3, sorry, 1, 2, 4, and 8. So if we were to write 8 is equal to 2 times 4, that is, we have written 8 in its factors, meaning we have factorized it. So if we write 8 is equal to 2 multiplied by 2 multiplied by 2, that is 2 multiplied by itself 3 times. We have factorized 8 in prime factors. So we have written 8 and its prime factors. Prime numbers all have only 2 factors, namely 1 and the number itself, e.g. 7 has no other factors than 1 and 7. Another such a number is 11. You can try to list the prime numbers. It's 1, 2, 3, 5, 7, 11, 13, 17, 19, 23. So all these numbers are prime factors. That is, they only have 2 factors, that is 1 and the number itself. Okay, next we look at the lowest common multiple. A multiple of a number is found by taking the product of that number and any counting number. For example, to find the multiples of 3, multiply 3 by 1 to get 3, multiply 3 by 2 to get 6, or multiply 3 by 3 to get 9, 3 by 4 to get 12, 3 by 5 to get 15. So listing them is 3, 6, 9, 12, 15, 18, 21, go on. To find the multiples of 5, multiply 5 by 1, 5 by 2, 5 by 3, and so on. Therefore, the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, and so on. So I have 2 numbers and wish to determine the lowest common multiple of the 2 numbers. We want the smallest number, which is a multiple of both numbers. So it's gonna be the smallest multiple of both numbers. Let's look at the examples. Determine the LCM of 6 and 8. So we have 2 methods. Let's check at let's look at the first one. The first one, the multiples of 6 are 6. That is 6 times 1, get 6. And the second one will be 6 times 2, which is 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30, and so on. And the multiples of 8 are 8 times 1, that is 8. 8 times 2 is 16. 8 times 3, 24. 8 times 4, 32, and so on. So as you will see that the lowest of all those multiples is 24. So we say the lowest common multiple of 6 and 8 is 24. So let's look at the second method. First, we factorize 6 and 2 in their prime factors. We have to write them in their prime factors. Let's have a look. 6 and written in its prime factors will be 2 multiplied by 3. And then 8 written in its prime factors is 2 multiplied by 2 multiplied by 2. Now, to determine the LCM, we write down the prime factors of the first number, that is 2 multiplied by 3. Now see which prime factors of the second number have not been written down yet. We see that the prime factors of the second number, that is 8, are 2 times 2 times 2. Of the 3, only 1, 2 has been written down. So we must add another 2's as factors of the LCM. So we have to add 2 2's of the second number, that is 8. We take the 2 2's to write the LCM. So the LCM will be 6 equal to 2 times 3, 8, which is equal to 2 times 2 times 2. We'll first take 2 times 3, and then because 1, 2 of the 3 2's of 8 have already been written, so we will take only 2. That is 2 times 2. So the LCM will be 2 times 3 times 2 times 2, which is equal to 24, which is the same as the one we got in the first method. So in the first method, we said 6, 12, 18, 24, and we said 8, 16, 24. So we got the LCM as 24. The second method, you just list the prime factors of both numbers. You first write the LCM, you first write the prime factors of the first number, and then you look at which factors have not been written down of the second number, and then you just take those that have not been written, and then you multiply all your factors. Let's look at another example. Determine the LCM of 50, 60. The solution, method 1, we have 50. Okay, this is actually the second method, the one of listing prime factors. Okay, let's see. 50 is equal to 2 times 25, which is equal to, I see that 25 can also be written down in prime factors as well, which is 5 multiplied by 5. So you get 2 multiplied by 5 multiplied by 5. And then the second number, 60, you have 2 times 30, where 30 can also be factorized, and 2 times 15. And then you see that 15 can also be factorized in its prime factors, that is 3 times 5. So the 60 will be equal to 2 times 2 times 3 times 5. And therefore, the LCM is equal to 2 times 5 times 5. You can take the whole thing, 2 times 5 times 5, and then go to the second number, that is 60. We have 2 5's in the first number, so 2 times 5 times 5, and then multiplied by, we have already written down 1 2 of the second number, so you don't have to include that. And then we have 2 multiplied by 2 multiplied by 3, and then 5 has already been written, so it will be 6 times 5 times 5 times 3 times 2, or 2 times 5 times 3 times 2 times 5. So when you multiply all those, you get 300. Method 2, you list the multiples of 50. 50 times 1, 50, 50 times 2, 100, 50 times 3, 150, 50 times 4, 200, up to 50 times 6, where you get 300. Then the second number, 60 times 1 is equal to 60, 60 times 2 is 120, 60 times 3, 180, up to 60 times 5, where you get 300. You will see that as you list them, the lowest common of the two numbers is gonna be 300, like we got in the first method. Okay, look at the other example. Determine the LCM of 3 numbers now. That is 3, 8, and 24. 3 is equal to 3 times 1. So 3 is the same as 3. So if we were to factorize in its prime factors, it's going to be 3 times 1, which is 3. And then the second one, 8, written in its prime factors, is 2 multiplied by 2, and then multiplied by 2. And then 24, 2 times 2 times 2 times 3, which is equal to, you take the prime factors of all these numbers, you get 3 for 3 multiplied by 2 multiplied by 2 multiplied by 2. That is the second number. So 24 is equal to 2 times 2 times 2 times 3. So which is all the factors of 24 all those prime factors of 24 have already been written down. So there's no need to write any of those down. So we have 3 multiplied by 2 multiplied by 2 multiplied by 2. So what is the answer? 3 times 2, 6 times 2, 12 times 2, 24. So the lowest common multiple of the three numbers, that is 3, 8, and 24, is 24. Write it down. Equal to 24. Okay. Let's look at the second method. We list the multiples of 3. It's 3 times 1, 3. 3 times 2, 6. 3 times 4, 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 3 times 7, 21. And 3 times 8, 24. 3 times 9, 27, and so on. Multiples of 8, called 8 times 1, 8. 8 times 2, 16, 24, 32, 40. The multiples of 24 will be 24 times 1, which is 24, 24 times 2, 48, and so on. So looking at the list, you see that the lowest common multiple of those three numbers is 24. There is 24 in 3, and there is 24 in 8, and then there is 24 in the multiples of 24. So the lowest common multiple will be oh, is it? Sorry. Okay, I'm sorry guys, let me reshare. Is it up again? Okay. Thanks guys. Okay, so the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 8 are 8, 16, 24, 32, 40, 48, and so on. 24 will be 24, 48, and so on. So you see, looking at the list, you see that the lowest of those multiples is 24. So the LCM of 3, 8, and 24 is 24. Okay, an exercise for you guys. Find the LCM of the following: 4 and 8, 6 and 16, 5 and 30, 5 and 30, and 14 and 20. Four and 3, 6 and 16, 5 and 30, 4 and 20. Try to use both methods. Try to use both methods just to see if you're getting the same answer. Okay, guys. Brilliant. I see. There are answers that I see. Well done to you guys. And I'm just hoping that everyone has got the same answers. Okay, number one, LCM of 4 and 6. So the first method would be to list the multiples of 4 and then list the multiples of 6. So 4 and 6, 4 times 1 is 4, that is this one's for 4. 4 times 1 is 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, and so on. And then 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24. And then on the list, you see that the lowest common of them all is 12. Therefore, 12 is the lowest common multiple. Okay. Number 2, 6 and 16. 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24, 6 times 5, 30, times 6, 36, 6 times 7, 42, 6 times 8, 48, so on. 16 times 2, 6 times 1, 16, 16 times 2, 32, 16 times 3, 18, and so on and so on. So looking on the list, you will see that the lowest common of them all of those will be 48. So the LCM of 6 and 16 is 48. Okay, the third one, the lowest common multiple of 5 and 30. So 5, 10, 15, 30, 35, 40, 45. And then for 30, we have 30, 60, 90, 120, 150, and so on. And then the lowest common of them is 30. Therefore, 30 is the lowest common multiple of 5 and 30. And even if you go to number 4, 14, 28, 42, 56, 70, 84, 98, 112, 126, 140, 154. And then for 20, you have 20, 40, 60, 80, 100, 120, 140, and 160. And then the one that is the LCM is 140. Okay, let's look at how you go about using the other method. Okay, 4 and 6. Number 1, list the prime factors of 4 as 2 times 2. And then prime factors of 6 will be 2 times 3. And then the LCM will be 2 times 2. That is those of 2. And then going to the second number, you see that 2 has already been written. Then we take only 3 and then multiply by 3. So 2 times 2 multiplied by 3 to get 12. So which is the same answer as we got using the other method. Number 2, 6 and 16. We have 6 is equal to 2 multiplied by 3. And then 16 is the same as 2 times 8. And then we see that 8 can also be written in its prime factors as 2 times 2 times 2. Therefore, the prime factors of 16 will be 2 times 2 times 2 times 2. So the LCM will be 2 times 3. And then we see that one of the 2's in the second number, that is 16, has already been written. So we will take only 3. So we have 2 times 2 times 2. So 2 times 3 times 2 times 2 times 2 to get 48, which is similar to what we got using the other method. Let's look at number 3. We have 5 and 30. The prime factors of 5 are equal to 5 and 1. So it's going to be 5 multiplied by 1. Those of 30 are equal to 2 times 15. 15 can be written in its prime factors as 3 multiplied by 5 as well. So therefore the LCM is equal to 2 times 3 multiplied by 5, or 5 times 2 times 3, which is the same. So you get 30, which is the same as the as what we got when you use the other method. Okay, number 4, we have 14, which is equal to 2 times 7, that is in its prime factors, and then 20 is equal to 2 times 2 times 5. So the LCM is equal to 2 times 2 times 5 times 7. So 2 times 2 times 5 times 7. So we get 140, which is similar to the answer that we got also using that other method. Okay. I think let's continue. Okay, the other thing we look at is fractions. Okay, a fraction is a numerical quantity that is not a whole number. A fraction consists of a numerator and it consists of a denominator, e.g. 3 divided by 4. So the number on the top, we call it numerator, and the one at the bottom, we call it the denominator. So the numerator tells us how many parts of the denominator there are. Thus, there are 3 quarters in a 3/4. Okay. So types of fractions. The first one is a proper fraction. What is a proper fraction? A proper fraction is a fraction with a numerator that is smaller than the denominator. We have the numerator being smaller than the denominator. Examples are 3/7. Number 2, 2 divided by 5. And the other one we have 13 divided by 15, 17 divided by 25. And then the second type is the improper fractions. An improper fraction is the opposite. That is, the numerator is bigger or larger than the denominator. So e.g. 3/2, 5/4, 11/9, and 25/17 are all examples of improper fractions. Okay, we also have mixed fractions. Mixed fractions are the combination of a whole number and a proper fraction. Consider the improper fraction 3/2, meaning 3 halves. We know that 3 halves are equal to 1.5, which we call a mixed fraction. How did we get to 1.5? Note we divide the numerator by the denominator. This gives us the integer, with the remainder being the numerator over the existing denominator. So this gives us an integer with the remainder being the numerator over the existing denominator. So let's look at it again. We have 3 divided by 2. So how many 3's and how many 2's and 3? That'll be 1. That gives us the whole number. And then the remainder is 1. So 2's and 3, there is 1. And then the remainder is 1. And then the denominator of the fraction remains the denominator. So this gives us the integer with the remainder being the numerator over the existing denominator. We don't change the denominator. Let's look at the examples. Change the following improper fractions into mixed fractions. We have 7 divided by 5. Dividing 7 with 5, we get 1. So there's only 1 5 in 7 with a remainder of 2. So therefore, 7/5 is equal to 1. That is the whole number. 2/5. So 17/6, if we divide 17 with 6, we get 2. That is, there is 2 6's in 17. And then the remainder is 5. Therefore, 17/6 is equal to 2 5/6. Mixed fraction can also be converted into improper fractions. That means we can go the other way around. Multiply the whole number by the denominator and add this answer to the numerator with the denominator staying the same. So we're going the other way around now. We have 2 5/6. So the rule says multiply the whole number by the denominator, that is 2 multiplied by 6, and add this answer to the numerator. So 2 times 6 plus 5, which is our numerator, with the denominator staying the same. So the denominator will stay the same, that is our 6 will stay as the denominator. We have the denominator multiplied by the whole number, and then we add the answer to the numerator, and then the denominator stays the same. So 2 times 6 plus 5 divided by 6. So we get 2 times 6, which is 12, plus 5 divided by 6 is equal to 17/6. Okay, so simplification of fractions. If both the numerator and the denominator of a fraction are multiplied or divided by the same number, the fraction does not change, as it still represents the same quantity. To have a fraction in its simplest form, we want the smallest possible numbers in the numerator and the denominator, and still have a fraction with the same value. Okay, let's look at the examples. If we're given a fraction 6 divided by 18, so what do? We want to simplify this fraction. So we write both the numerator and the denominator into their prime factors. Then we have 6 divided by 18 being equal to, the prime factors of 6 will be 2 times 3. And then those of 18, we can write 18 as 2 times 3, 2 times 9, sorry. And then 9 can also be written in its prime factors, which is 2 times 3 times 3. And then we have 2 times 3 divided by 2 times 3 times 3. Okay, so we find the common factors in the numerator and the denominator. So we cancel them out and rearrange your remaining factors. So we have 2 at the top and 2 at the bottom. Those will cancel each other. We have 3 on top, then we have another 3 at the bottom. So those will cancel each other. And then what is left is 1 divided by 3. So that means we have simplified the fraction. So it remains the same value, but we have simplified or written it in its simplest form. Okay. Let's look at other examples. We're given 12 divided by 16. So let's write it in its simplest form. So we have 12, which can be written as 2 times 6. And we know 6 can also be written as 2 times 3. So the prime factors will be 2 times 3 times 1. You can even not write that one, the last one, that is times 1. And then divided by 2 times 8, whereas 8 can also be written in its prime factors. We have 2 times 2 times 2 times 2. And then we see that there's 2 and there's 2 at the bottom that cancel each other. And then there's another 2 and 2 at the bottom that cancel each other. And then we're left with 3 times 1 divided by 2 times 2, which is equal to 3 divided by 4. That is in its simplest form. The other example is 18 divided by 24, 2 times 9 divided by 2 times 12. So rewriting 9 and 12 in their simplest, their prime factors, we have 2 times 3 times 1 times 3, 2 times 2 times 2 times 3. And then 2 and 2 cancel, 3 and 3 cancel, we're left with 3 times 1 divided by 2, 2 times 2, which is equal to 3/4. Okay, some exercise for you guys to change the following improper fractions to mixed fractions. change the following improper fractions to mixed fractions. I'll just go back a bit. Okay, we divide the numerator by the denominator, which gives us the integer with the remainder being the numerator over the existing denominator. That is the important thing to note. We divide the numerator by the denominator, which gives us the integer with the remainder being the numerator over the existing denominator. Go back. All right. Eight over 3, 9 over 4, and 14 over 5. Okay, well done, guys. Well done, everyone. Let's look at the answers. Change the following improper fractions into mixed fractions. So 8 divided by 3. First, we divide 8 by 3 and get 2. 3 is in 8, there will be 2, which remains our whole number, with a remainder of 2, which becomes the numerator, and then we don't change the denominator, the existing denominator, which is 3. So we have 8, we've got 2, 2 over 3. And then the second one is 9 over 4. We divide 9 by 4, we get 2, and then the remainder is 1. So that remainder becomes our numerator, and then we don't change our denominator. Therefore, 9 over 4 becomes 2 quarters, 2 1 over 4s. Okay, and then C, 14 divided by 5 is equal to 5 over 14. 5's in 14, there will be 2, and then the remainder is 4, and then the existing denominator we keep. So 2, 4 over 5. So well done, guys. You got those correct. Okay, number 2 says change the following mixed fractions to improper fractions. Let's go the other way. We have the mixed fractions now. We want to change to improper fractions. Remember, the whole number is will be multiplied by the denominator, and then the answer is added to the numerator, and then you keep the existing denominator. Okay. All right, brilliant, guys. I see that you guys are getting there already. Let me share just to confirm the answers that you got. Okay, for number 1, that is A3, 1 over 3. So the rule says the whole number multiplied by the denominator, and then you add that to the numerator, and then you keep the same denominator. So we have 3 multiplied by 3 plus 1 divided by 3. So 3 multiplied by 3 gives us 9, plus 1 gives us 10, which gives us 10 over 3. Okay, well done. The second one was 8, 3 over 7. So we get 8 multiplied by 7 plus 3 divided by 3. So we have 8 times 7, which is 56, plus 3, 59 divided by 3. Okay, number C, 7, 4, 5. We have 7 times 5 plus 4 divided by 5. 7 times 5, 35, plus 4, 39. So we get 39 divided by 5. So that's how you go about it. Most of you guys got it correct. Let me motivate you guys to keep sharing the answers. Share the answers on the chat so that I can see how you guys are progressing. And then if I see an error, we're gonna correct it. That way, you will be on the right track. You get corrected, and then you move on. So it's just the slight mistakes at times that you need to be careful about. And then I think if you keep sharing and then we correct those, you will be perfect. Okay. So the exercise, convert the mixed fraction to improper fraction. That is 2, 3 over 8. Can you convert that into? Okay, let's start there. Convert that into a mixed fraction. Convert that mixed fraction into an improper fraction. Okay. I see somebody has got it correct already. Yes, brilliant. Okay, well done, guys. Let's go to the next exercise. The next exercise says simplify the following fractions. Write them in the simplest form, in their simplest form. So we have 7 divided by 14, we have 20 divided by 15, 14 divided by 16, and then we have 8 divided by 12. So remember, the first thing is to write each one of those, that is the denominator and the numerator, in their prime factors. Write them in their prime factors, and then you cancel what needs to be cancelled, and then you'll get your simplified form of each of those fractions. Write the denominator and the numerator in their prime factors, and then cancel what appears to be the same in both the numerator and the denominator. And then whatever is left, you rewrite. So that will give you the simplified version, or the simplified form of your fraction. All right, let's proceed. I see only one person shared. Only one person shared the answers. Well done to you. Let's go on. Let's proceed and look at the answers just to confirm. Okay, number one. Okay, 7/4 written, its prime factors will be 1 times 7 or 7 times 1, and then 14 will be 2 times 7. Then we see that 7 and 7 cancel each other. We're only left with 1/2. So well done, guys, you got that correct. So 7/4 in its simplified form is 1/2. So it's actually saying how many sevens in 7, there's going to be 1. How many sevens in 14? In 14, then it's 2. Was it? Okay. Apologies for that. Let me reshare. Okay, please indicate, guys, if it's up. Is it visible again? Is it still not showing?
It's showing.
All right. Thank you. Thank you. Okay, so 7/14 is like saying sevens in 7, there's 1. Then sevens in 14, there's 2. So 1 times 7 divided by 2 by 7. 7 and 7 cancels out. We're left with 1/2. Okay, number 2, 20 divided by 15 is equal to 2 times 10 divided by 5 times 3. So 10 can also be written in prime factors as 5 times 2. So we have 2 times 5 times 2 divided by 1 times 5 times 3. And then 5 and 5 cancels out. We're left with 2 times 2 is equal to 4 over 3. So we get 4 over 3. And then number 3, 14 divided by 16. Writing 14 in prime factors, we have 2 times 7 times 1 divided by writing 8 in prime factors will be 2 times 8, which can be written as 2 times 2 times 2 times 2. So we have 2 times 2 times 7 times 1 times 1 divided by 2 times 2 times 2 times 2. And then the 2 on top cancels the 2, 1, 2 on the 2's that are at the bottom. So we have 7 divided by 2 times 2 times 2, which is 8. So it's equal to 7 over 8. Okay, number D, 8 divided by 12. Write 8 in prime factors. So we have 2 times 2 times 2 divided by 2 times 2 times 3. So 2 2's cancels the 2 2's at the bottom. 2 2's on top cancel the 2 2's at the bottom. So we are left with only 2 and 3 at the bottom. We have 2 is 2 divided by 3. So brilliant, guys. Okay, what's next? It's the multiplication. Let's look at the multiplication of fractions. So there are 3 simple steps to multiply fractions. So the first one, you multiply the numerators. The second one, you multiply the denominators. And then you simplify the fraction if needed. So multiply the numerators, multiply the denominators, simplify the fraction. So examples have 2 divided by 3 multiplied by 5 over 7. So first step, you multiply the numerators. Second step, you multiply the denominators. So we have 2 times 5 and then 3 times 7. And then that gives you 10 divided by 21. So that fraction is in its simplified form. So you can't simplify it any further. So 3 divided by 4 multiplied by 2 over 3. Okay, simplify the numerators, simplify the denominators, and then simplify. So 3 times 2 divided by 4 times 3. And then we get 6 divided by 12. And then we have to simplify. Simplifying, we write 2, the prime factors of these numbers, so 6 and 12. So we get 2 times 3, and then we get what? 2 times 2 times 3. So 2 times 3 at the top will cancel the 2 times 3 at the bottom, and then we'll be left with only 1 at the top divided by 2. So that will be 1 over 2. That is the simplified version of that fraction. That is 6 over 12. Okay, next is the division of fractions. So there are 3 steps to divide fractions. So you invert, that is turn around the second fraction, and make the division sign a multiplication sign. So you invert, that is you turn around the second fraction and make the sign, the division sign, a multiplication sign. Then you multiply the first fraction with the inverted second fraction, simplify the resulting fraction if possible. Let's have a look at the examples. Okay, we have 4 divided by 7 divided by 7 over 14. So the rule says we invert, or we turn around the second fraction, and then we change the division to a multiplication. So we have 4 over 7. We change the second fraction, that is 6 over 4, into 14 over 6. So it's going to change into 14 over 6, and then we change the division into multiplication. So we have 4 divided by 7 multiplied by 14 over 6. And then now we multiply. Okay, you can just multiply straight, or you can just change write everything into its prime factors to simplify. 2 times 2 times 2 times 2. So that is 14 in its prime factors. That is 2 times 7. And then 4, 2 times 2. Okay, divided by 7 in its prime factors, 1 times 7. Multiplied by 6 in prime factors is 2 times 3. And then the 2, there's going to be 1, 2. That cancels the other 2 at the bottom. And then so we'll be left with 2 times 2 times 7, but we still have the 7 at the bottom, so the 7 and the 7 cancel out as well. So we get 2 times 2, which gives us 4, and then divided by what is left at the bottom, which is 1 times 3, which is 3. 4 over 3. Okay, the second one is 3 times 8. Okay, 3 divided by 4 times 8 over 9. Okay, that is the simplification. 3 times 2 times 2 times 2 divided by 2 times 2 times 3 times 3. So 3, 1, 3 at the top, cancels the other 3 at the bottom. And then we have 1, 2 at the top, cancelling, okay, the 2 2's at the top, cancelling the 2 2's at the bottom. And then we're left with 2 over 3. Okay, the third one, there's 3 fractions that are being multiplied there. 3 divided by 8 times 16 over 25 times 7 over 10. So it's 3 multiplied by 16 in prime factors. It's 2 times 2 times 2 times 2. And then 7 in prime factors is 7 times 1. And then 8 in prime factors is 2 times 2 times 2. And then 21 in prime factors is 3 times 7. And then 10 in prime factors is 2 times 5. And then you cancel whatever appears at the bottom and top. We have 3 cancelling a 3, and then 2, all the 2's cancelling out. And then we're left with only 1 over 5. Okay, D, 5 divided by 6, 5 divided by 6, all divided by 1 over 2, over 12, sorry, multiplied by 3, divided by 15. So the operations here is division and multiplication. So we operate from left to right. That is, we start at the division and then we go deal with the multiplication later. Okay, let's start with division. We have 5 divided by 6. Because the rule says the second fraction that is dividing has to be inverted, that is turned around. So we turn it to 12 divided by 1, and then we change the division sign to multiplication. That is, we get 5 divided by 6 multiplied by 12 divided by 1 multiplied by 3 divided by 15. So after that, now we see that there's multiplication and there's multiplication. So we can just multiply throughout, that is the numerators alone, and then the denominators alone. So we have 5 multiplied by 2, that is 12 in prime factors, gives us 2 times 2 times 3, and then times 3. And then 6, 2 times 3, and then 15 times 3 times 5. And then we cancel whatever appears at the top and at the bottom at the same time. So we get our answer is 2. So what is left is 2. There is an exercise for you guys. Simplify the following fractions. You have 3 over 4 multiplied by 1 over 3. Then 3 over 4 divided by 1 over 3. Number 3, 3 over 7 divided by 9 over 21. Number 4, 5 divided by 6 multiplied by 1 over 4 divided by 5 over 3. Please work those out and again share your answers in the chat section. All right, I see that you worked them out. Okay, so obviously number one is 3 times 1, which is 3. 4 times 3, which leads us to saying 3 cancels 3, and then we are left with 1/4. So I see you got that one correct, guys. And then the second one is 3/4 divided by 1/3. So we invert the second fraction and change the division into multiplication. So we have 3/4 multiplied by 3/3, which gives us 9/4. I don't have the third and fourth solution, but I see you guys got it correct. So we have 3/7 divided by 9/21. So you change the second fraction into 21/9 and change the division into multiplication. So 3/7 times 21/9. So 21 you can write as 3/7, sorry, 3 times 7, and then 9 can be written as 3 times 3, and then the 7 at the top is going to cancel the 7 at the bottom, and then you're going to get 3 times 3, which is 9, divided by 3 times 3, which is 9. 9 divided by 9 is equal to 1. Okay, number 4, 5 times 1 divided by 6 times 4, divided all multiplied by 12 divided by 5. So the 5 and the 5 cancels out. We are left with 12/6 times 4, which is 24, which leads us to 1/2. That will leave us to 1/2. You guys got that one correct. All right, well done, guys. I think that's what was prepared for today. But I want to share for the few remaining minutes. I'm gonna share the question paper that we can look at it and discuss. I remember I left you with a few screenshots that I said you should take and practice. I don't know if you guys did those questions. But let's go back to that question paper. Mm. Yes. Okay, is it up, guys? Can you see it? Can you guys see the question paper? Somebody please unmute if you can see and just let me know. Still nothing. Okay, I see one thumbs up. I'll assume everybody can see. Okay, there's a question. A biscuit manufacturer uses 200 grams of flour, 50 grams of sugar, and 100 grams of butter. So the question says, write an expression for the amount of butter that is needed to produce X packets of biscuits. So the total amount of butter that is needed to produce X packets of biscuits is equal to the 100 grams, that is the amount of butter, and then it's 100 grams of butter, or 100 grams multiplied by the number of packets that are produced, which is X. So it's 100 grams multiplied by X. So 100 X grams should be 100 X grams, not 100 X kg. We see that everything that is in those questions is in kgs, but we are given grams. So we have to convert the grams. If this was in grams, if this was in grams, all of these were in grams, so we would take number one as 100x grams, but now we have 100x kilograms. So the first one is out, so we have to convert the 100 grams into kilograms. We have 100 grams, convert 100 grams to kilograms, so we have 100 divided by 1000. So 100 divided by 1000, so we're converting to kilo. So we have 100 divided by 1000 to get 0, is it 0,1? It should be 0,1. So to confirm, so please confirm it, guys. So we have so it's gonna be 0,1 x kilograms. So it's 0,1 x kilograms. So that means option 3 is correct. So so can you write me, I'm gonna ask you to write me the an expression for the amount of flour that is needed. What will be the expression for the amount of flour? I've just given you an answer to the amount of butter that is needed to produce X packet. So I want you to write the amount of flour that is needed, the expression for the amount of flour that is needed to produce X packets of biscuits. So I want you to write that one in kilograms as well. I've just given to you that conversion from grams to kilograms, you divide by 1000. So I said the amount of butter will be 100 divided by 1000 kilograms multiplied by X packets of biscuits. So which gives me 0,1 X kilograms. 0,1 X kilograms. So I want you to give me an expression for the amount of flour that is needed to produce the X packets of biscuits. And then maybe also write write that one for the sugar as well that is needed. I won't keep you guys for too long. I've got another commitment at 12 o'clock. There's another session that I have to be into at 12 o'clock. So I'm gonna try and finish at 12. We're gonna finish at 12. So we're gonna finish at 22. That is in 6 minutes. Okay, yes, that is brilliant. So the amount of flour will be 0.2 x kgs, and then the amount of sugar that is needed will be 0.05 x kg. So we had 200 grams. So convert that 200 grams into kgs by dividing by 1,000 to get 0.2. And then you multiply by the amount of packets, which is x. So you get 0.2 x kgs. And then you get 0.05 x kgs. Well done, guys. And I hope everyone is following. Okay, another question that we can quickly look at in 3 minutes is look at the second question. Second question, which is simplify the following expression as far as possible. Simplify the following expression as far as possible. Remember when we dealt with the first session, we dealt with the simplification of algebraic expressions. We expanded the brackets. Remember we used the method of expanding the brackets. So that means everything that is outside the bracket multiplies everything else that is inside the brackets to break the brackets. So we will have 2b squared multiplied by a minus 2b squared multiplied by -1. And then that one we're done with that bracket. And then we go to the second one, minus 8a multiplied by b squared, and then plus 8a multiplied by 1. So which expression describes, so is it 1, 2, 3, or 4? Which best describes that expression? Oh man, the screen is gone. Is it up? Okay. I see it's 22. Let me give you guys 2 minutes. Let me give you 2 minutes to share your answers. Okay, we have 2b multiplied by a minus 1 minus 8a multiplied by b squared plus 1. So I said 2b squared multiplied by a minus 2b squared multiplied by 1. And then the second bracket, we have minus 8a multiplied by b squared plus or minus 8a multiplied by 1. 8a minus 8a multiplied by 1. So which of those is 1, 2, or 1, 2, 3, or 4 describes that expression? Okay, the time is 11:42, and I think I'm gonna have to run through it. Okay, so the first one is to be, okay, so if we open the first bracket, we get 2b squared a, 2b squared a, and then multiplied by -1, we get minus 2b squared. So we have 2b squared a, 2b squared a minus 2b squared. And then the second bracket is minus 8 a squared, a b squared, sorry, negative 8a b squared minus 8a. So the 8a is negative. I see that on the third one, in the third one, 8a is positive, so it's out. So we should have a negative 8a. So the third one is out. So we have 2a b squared and negative 2a b squared. Positive 2a b squared and negative 8a b squared. 2ab squared minus 8ab squared. That gives me negative 6. So it's 8 and 2. 2 is positive and 8 is negative. So it's going to be 8 minus 2, which is 6. But the answer is negative because the 8 is negative. So it's going to be negative 6 8b squared. So let's go look at the options there. We have a negative 6 ab squared. So that is the second option. I have negative 6. The first one is out because there's nothing that has a 6 ab squared. So that is, it's out. So we have 2ba squared. So the one I've eliminated 2. So the first one and the second one and the third one, because the 8 is positive on the third one, so it's out. My 8, when I ran through, it was negative. So it's 3 is out, and then 1 is out because I have 2ba squared. I don't have anything that has an a squared in that expression in my multiplier. When I broke those brackets, I didn't get anything that has 8a squared. So the first one is out, the third one is out. So we look at the second one. So the second one has a negative 6ab squared, which is what I got when I said 2ab squared and negative 8ab squared. I got a negative 6ab squared. And then I got a negative 8a. So the second one also has a negative 8a. So the negative 8a, I got it when I multiplied on the second bracket by negative 8a and 1. So negative 8a multiplied by 1 gave me a negative 8a. So I'm still in the second option. So I have a negative 8a. I have a negative 6ab squared. So let's see what's next. So I have a negative 2b squared. So the negative 2b squared, I got it when I multiplied 2b squared with negative 1. I got negative 2. So my correct option is the second one, because it's negative 6ab squared minus 2b squared minus 8a. So I hope you guys followed that. I hope you guys followed how we got to the second one. We will continue with this question paper again when we meet. We will do what we do, and then at the end of the session, we will look at the question paper again to see if we can answer more of the questions that are applicable to what we have done so far. All right, I'm very late. I'm very late for my session. So I think, guys, let's adjourn for today. I don't know I think we are meeting again on Wednesday. I don't know if we're meeting, when is the 16th? I think we're meeting again on Wednesday next week. So I'm hoping to hear from you again on Wednesday next week. Otherwise, have a good day further and a nice weekend. Thank you all for attending and being part of this session, and appreciate your participation. Remember that you have to practice to be perfect. So thank you again for coming. Okay, bye guys.